In this question, we have a tangent to the curve of f of x equals 1 over x, where x is greater than 0. This tangent has an equation y equals mx plus 2, where m is less than 0. We have to find the value of m. Now guys, this can be a particularly knotty question if you don't know how to start. And this question is very tricky because all we know is that the y-intercept of the tangent is 2. So we're really, even though it's probably around about the right level of challenge for an exam 1 style question, it can be very difficult to get your head around where to start, and that is because no information is given about the intersection point of the tangent with the curve. So you've got to make a start, and you've got to call that intersection point something, some pronumeral, and that is then how you get your intro into how to do the question. I'll show you. It's very important that you understand this, because there was a question in an end-of-year VCAR methods exam recently which just absolutely did students' heads in. It was towards the end of the paper, and it's very similar to this kind of question, so please watch carefully and know how to do this. We let the point of intersection of f of x with the tangent be. We're calling it a. You can call it anything you like, but I'm going to call it a. And then of course, because f of x is 1 over x, it's going to be a comma 1 over a. Now you draw a picture. You draw a picture with that information in there, okay? A and 1 over a, and then of course you've got this information over here, which is 0 and 2. That's the y-intercept of the tangent, okay? Now I think you can see that once you lock in a y-intercept of 2 here for the tangent, there is only one line, one straight line graph which is going to work as being tangent to this function here, this function 1 over x, right? So it's fully constrained, and we should be able to use the information that we've got to zero in on game plan what is the value of a. If we can get the value of a, then we can get the value of the gradient, because we've got the rule of the function, the actual value of the gradient, which of course is the same gradient as the tangent, and that's what we're being asked for. Okay, let's go with it. If f of x is 1 over x, therefore the gradient function is minus 1 over x squared. And of course, if at the intersection point of the curve with the line, x is a, then we have a specific value of the gradient of minus 1 over a squared, don't we? Now, armed with that information, all we've got to do is make the connection of the gradient of the curve with the gradient of the tangent. And we can do that using this point here and this point here, using y2 minus y1 over x2 minus x1 equals m, the gradient of the line, which is the same as the gradient of this curve. And that information will give us the value of a. You watch. M of the tangent equals, okay, y2 is 2 minus 1 over a over 0 minus a, and of course that's equal to minus 1 over a squared. Now we've got this neat little equation in a, which we can solve for a as follows. There it is, okay, now we're just going to clean that up a little bit now with this business down here. We need to fix that up a bit. And that gets us that, and why don't we just clean that up a little bit more into that form there. Okay, now, so we can basically say that 2a minus 1 must equal 1, I would say, wouldn't you? Yes, after the cancelling. And therefore, if 2a equals 2, therefore a is going to equal 1. Okay, now, so isn't that amazing? A equals 1. So the point of intersection here, guys, with the tangent and the curve, where the tangent goes through this point here, is 1 and 1. Alright? Now, the last little step. So the gradient of the curve and the tangent when x equals a equals 1, of course, is minus 1 over a squared, which is going to be minus 1 over 1 squared, which is just going to be minus 1. Therefore, guys, looking back at the question, find the value of m. Therefore, m is minus 1. Absolutely fantastic, isn't it? So, please know how to do that. Get a starting point by calling this thing some pronumeral and then going from there, just using the information they give you in the question to sort it out. Alright, thank you very much, and we'll see you soon.